Hello, everybody. Video 8, and this is the last video lecture for the unit. Reading, interpreting entropy. What's going on with entropy and randomness? More entropy than enthalpy at this point, because we already done enthalpy. We need entropy. Very similar words, guys. I apologize for this. I didn't make them up. The laws of thermodynamics indicate that all atoms will be stable at their lowest energy state possible. Okay, so this is another fundamental theme of the universe that I'm trying to get you to see big picture style. Okay, we like low energy. Okay, these laws also indicate that therefore the universe favors randomness in disorientated state, hence high entropy, because this is lower energy. It takes me a lot of energy to build a castle out of Legos. Eventually, nature wants that thing to fall apart and that energy to go away. It's just how it is. So, particle diagrams for each of the following phases. So remember, solid is going to look something like this, right? I want the circles to be touching. It comes out a lot darker on my smartboard than it does on my computer monitor, so hopefully you see the light blue on the computer monitor. Okay, they should be touching and they should be rigid. Liquid, and there's no randomness, right? Liquids have a little bit more randomness just because they take the bottom of the container, but they can move, correct? So they have a little bit more randomness. These are all going to be kind of in order, and this is going to end up being just what phase are we in. Now, aqueous is slightly more random than pure liquid, because a pure liquid, we know who each neighbor molecule is going to be. Aqueous is two things now in that solution. So it's a liquid, but there's two things in there, so there's a little bit more randomness. If I was a water molecule, would my neighbor molecule be water, or would it be maybe the solute that's dissolved in there? It could change. So that adds that little bit of randomness. And then the ultimate randomness is gas, because gas is all over the place and they're just going in random straight line motion. So randomness is high when I'm going in random straight line motion. I can't even predict where I'll be in the container in the next few minutes because I could bump into something and go in a different direction. Okay. So entropy increases when the sample goes from solid to liquid, okay, or from anything when I'm going right on that last diagram. And your right is this way, isn't it? Samples are dissolved in water, becoming aqueous, okay? Samples are turned from liquids to gases, correct? A reaction produces a gas as a product when solids react. Perfect. A reaction produces more moles of product than moles of reactant. More moles is more random than less moles. So that wasn't on that original thing, but that's on there. So we have some examples we can do, and I think we've probably done it for examples. Yep. So let me just go through the examples and we'll talk about it. And this is all going to be based on phase. So first one, I have a solid going to a solid and a gas. Well, one thing going to two things is increasing randomness, and then I'm going from this gas here means I'm increasing my randomness or my entropy. All right, here I got H2O, 1 mole, but I'm going from liquid to solid. So solid is definitely more ordered. More ordered means decrease in entropy, okay? Here I have two gases becoming one gas. And I also have a total of 4 moles of gas on this side and just 2 moles of gas on this side. So my randomness is going down. I am making bonds and energy is going away. Hello. All right, NaCl goes, I have a solid going to two aqueous things. Notice I have one thing going to two things. Two things is definitely more random, especially aqueous. All right, solid to liquid, same thing. Liquid is more random than solid. Are we getting a feel for how we're doing this? Solid to gas. Gas is much more random, therefore my entropy is going up. So that's just how we do the whole thing. I'm not going to go through the whole example here. I think that you can basically follow along with the logic that I just used, and you can come up with the rest of how these work. And then you can always just check it in my packet if you are unconfident. But you should always check your work regardless. And guess what? We just finished the unit of kinetics and equilibrium. Happy chemistry, and everybody. And I just have to, find the button.